Today you're going to be doing an investigation called air pressure patterns. The questions you're going to be answering are: what is our weather, fair or stormy, when will it change, and what weather is headed our way? Your educational outcomes are: patterns of air pressure help us describe our current and forecasted weather. Air pressure is determined by the weight of the overlying air, and it varies from place to place and over time. Pressure variations bring about atmospheric motions that set the stage for much of the weather that we experience. Knowing the patterns of pressure across the country is basic to our understanding what the weather is and what it is likely to be wherever we live. After completing this activity, you should be able to draw lines of equal pressure, isobars, to show the pattern of air pressures across the nation at map time, and locate regions of relatively high and low air pressures on the same map. Investigations. Air pressures at any point on Earth's surface or in the atmosphere is equal to the weight per unit area of the atmosphere above that point. This means that air pressure drops with increasing altitude. Hence, the higher the elevation of the Earth's surface, the less air above and the lower the air pressure. Air pressures routinely reported on surface weather maps are values corrected to sea level. That is, air pressure readings are adjusted to what they would be if the reporting station were actually located at sea level. Adjustments of air pressure readings to the same elevation, sea level, removes the influence of the Earth's relief, topography, on air pressure readings. The adjustment allows comparisons of horizontal pressure differences that can lead to the recognition of pressure patterns. These patterns reveal existing broad-scale pressure areas which have a major influence on weather. Horizontal air pressure patterns on a weather map are revealed by drawing lines representing equal pressure. These lines are called isobars because every point on the same line has the same air pressure value. Each isobar separates stations reporting pressure values higher than the isobars from the stations reporting pressure values lower than the isobar. There are a series of questions that you're going to be doing in this investigation. Questions 1, 2, 3, and 4 we're going to be using this map right here, the smaller map. Questions 5, 6, 7, and 8 we're going to be using this bigger map here that's on your last page. All right, let's take a look at question number 1. The surface pressure map that follows shows air pressure in millibar units at various locations. Each number centers on the location it represents. The lowest plotted pressure is 1022 millibar, and the highest plotted value is what? Is it 1027? 1045 or 1046? Well, let's take a look at the map. You have to look at this map here and scour all the numbers, every single number, and figure out which one is the highest number before you make your choice on question number 1. Question number 2 says the 1024 millibar and the 1028 millibar isobars have been drawn. Complete the pressure analysis by drawing the 1032, 1036, 1040, and 1044 millibar isobars. Label each completed isobar by writing the appropriate pressure value as its ends are as shown. At its ends as shown. So you're going to be doing this right here. So they've done 1024 for you and drawn 1024 at the end. They've drawn 1028 for you and labeled it as 1028. You're going to draw in 1032, 1036, 1040, and 1044. Now, when you want to check your work, you have to ask yourself, is everything in between 1024 and 1028 in between those numbers? Yes? Yes. This one is drawn right across the 1024 because that's the 1024 line. Question number 3 says, by convention, isobars on surface weather maps are usually drawn using the same interval, the difference in air pressure value from one isobar to the next, as that used on this map. The isobar interval is blank millibars. So you have to look here and say, what is the difference between this 1024 line and the 1028 line? And then it goes 1032, 1036, 1040, 1044. What is it counting up by? That's the interval that's used on this map. The isobar interval is selected so as to provide the most useful resolution of the field data. Too small an interval will clutter the map with too many lines, and too great an interval will mean too few lines to adequately define the pattern. Question number 4 says, also, by U.S. convention, isobars drawn on surface weather maps are a series of values that, when divided by 4, produce whole numbers. So, for example, 1,000 divided by 4 is 250. That's a whole number. The progression of isobaric values can be found by adding 4 sequentially to 1,000 and or subtracting 4 sequentially from 1,000 until the full range of pressures are reported on the map that can be evaluated. Which of the following numbers would not fit such a sequence of isobar values? So you're trying to look here and see which one of these numbers would not fit that. You have 996, 1000, 1004, 1008, 1010, and 1012. Which one doesn't fit? Circle the best choice. Now, question number 5 says, the following data stream atmosphere map of pressures shows air pressures for a particular time on January 18th, 2009. The lowest plotted air pressure on the map is what? It's in the lower peninsula of Michigan. So for question number 5, you have to look at this map here on the back page and try to figure out what is the lowest reported air pressure, and they tell you it's in this area up here where Michigan is. Now, question number 6 says, the highest reported pressure is 1043 millibars in what city? Is it in Missoula, Montana, up in this region here, or is it in Texas, in Dallas, Texas, down here? Circle the correct answer. Question 7. The map analysis utilizing the conventional 4 millibar interval between isobars will require the drawing of isobar ranging from 1008 to what? 1040, 1042, or 1044. Note that although the lowest pressure on this particular map actually has the same value as an isobar that fits the interval series, the isobar is not being drawn as it occurs at a single point, and there are no pressures less than its value reported. Also, more than one isobar having the same value will appear in a complete analysis of the pressures reported on the map. The isobaric patterns across the western quarter of the U.S. and covering parts of Florida, Georgia, and South Carolina have already been drawn. So question number 7 basically is asking you to figure out what is the highest air pressure that you can see on the map, and therefore what is the highest isobar line that needs to be drawn, knowing that you're doing it in intervals of 4. Alright, finally we're coming to question number 8. Arbitrarily, we might start by completing the 1040 millibar isobar, the last of the series. In addition to those the isobars go through, the value of 1040 also appears in western Montana. The two ends of this isobar will connect to surround the highest pressure reading. Note that this isobar has been labeled with its value, 1040, on the isobar line. Place a bold H for high pressure over the highest enclosed pressure reading. So you're going to place that H on your map. Plotted pressure values outside of this closed isobar are what? Less than, equal to, or greater than 1040. So it's asking you to close up this isobar line right here, the 1040 isobar line. They've started it for you. They want you to close it up, and then they want you to place a big H there for high pressure, because this is the highest pressure area on the map. Then it's asking you, are the pressures outside of this 1040 line, are they less than, equal to, or greater than the pressures inside of the circle? Once you finish question 8, it says to continue drawing and labeling isobars by extending the ends of the already drawn isobar segments where they existed within the data pattern. We're not doing question number 9, but it does want you to complete as many of these isobar lines as you can on this map right here, and then label the map with an L for where the lowest pressure area is and an H for where the highest pressure area is. And then you're done.